Hello, and this is Matthew from Simplilearn, and today we're looking at how we can use Chef to improve the way that you administer hardware within your DevOps environment. There's going to be 6 things that we're going to step through. The first is really looking at what is the world that many of you already work in today? How do you administer your networks and your systems today? Then we're going to look at how Chef can be the tool that really helps improve the efficiencies of creating a consistent operations environment. We're going to look at the tools and the components and the architecture that it takes to construct Chef. And then finally, we're going to take a use case of one of the many companies that is using Chef today to improve the efficiency of their operations environment. So let's take a step back at what life was like before Chef. This may well be the life that you're experiencing right now. So as a system administrator, typically the way that you work is that you are responsible for the uptime of all of the systems within your network. And you may have many systems that you are responsible for. Now, if one system goes down, that's not a problem, because as a system administrator, you can get notifications and you can jump right onto the problem and solve it. When things start getting really difficult, however, is when you have multiple systems and you are not able as a single person to get to all those systems and solve them as quickly as possible. The problem that you start having is that your environments are not in sync. If only this could all be automated. Well, this is where Chef comes to the rescue for you. So let me take some time and introduce you to the concepts behind Chef and why it's a tool that you would probably want to be using in your environment. So what actually is Chef? So Chef is a way in which you can use code to fix your physical hardware environment. So what does that look like? Well, the way that we write out scripts in Chef is that you can actually code your entire environment. So you don't have to actually be managing your environment on a hardware by hardware basis, but actually use scripts called recipes that will actually manage the environment for you. So Chef will actually ensure that every system is automatically set to the right states that meet the requirements that you have defined in your code. So you don't have any issues where hardware starts to fail, because it references the code to reset the state within that environment. And that makes you a happy system administrator. So let's go through the mechanics of how this actually works with Chef. So Chef is ultimately an automation tool that converts infrastructure to code. And you'll often hear the term infrastructure as code, or IAC. And this really starts as an output of the work that Chef has done. Because you take the policies that you as an organization have created and you convert that into a scripted language that can then be implemented automatically. This enables Chef to be able to manage multiple systems very easily. And considering how broad and deep our systems become, it's very easy to see how this can help you as a system administrator. The code is then tested continuously and deployed by Chef so that you're able to guarantee that your standards and appropriate states for your hardware and operating environment are always maintained. So let's step through the different components that are available in Chef. So the first one is actually creating the actual recipes for Chef. So you actually work on these on a workstation and you'll write out your code, which is referred to as a recipe. And that recipe will be written using a language called Ruby. Good thing for you is that there are lots of examples of Ruby recipes that have been created by the open source community. A lot of examples. Knife is the command tool that you use that communicates between the recipes and the server. So your recipe is the instruction and Knife is the tool that makes that instruction work and sets the appropriate state on the server environment. When you create more than one recipe, you start creating a collection. Those collections are referred to as cookbooks. And you may take an environment such as a large network where you have multiple nodes, potentially hundreds of servers that have to all have a consistent and equal state environment, and you would put that cookbook and use that cookbook to ensure with Chef that the state of each of those nodes is consistent. And then Ohai fetches the current state of your nodes and then the Chef client configures the nodes as defined within your cookbook. So let's step through the architecture and working environment of Chef. So for an administrator, a systems administrator, you only have to now work from your workstation. And from that workstation, you can then configure all the nodes of your environment. You can use different recipes that you create, and those recipes can be compiled into a cookbook that can be then applied to a node. The thing that's of value is that as you change the environment, as you move and mature as an organization, and your nodes need to mature consistently and quickly with your organization, all you have to do is roll out a different recipe to your nodes, and then the nodes will use the tools within Chef to make the updates. So you can create a second recipe or even a third recipe to be deployed out to your server environment. Knife is going to be the tool that does the hard work of doing the updates on the server. With the server, you have your collection of recipes in a single cookbook. However, understanding the state of the individual nodes is important to ensure that the information is broadcast from the server with the instructions on how to set up the network within those nodes. In this instance, we use OHI, and OHI will fetch the state of the nodes and send that back to the server and get the information from the cookbook using the Chef client. In your Chef node network, there is the potential at times that maybe one of your node fails. If there are two failed nodes, then a request is sent back to the server, and information on the latest node structure that is identified and defined in the cookbook will be sent to the failed nodes. If that fails to reset the nodes, then the workstation is notified, and you as the administrator will receive a notification to manually reset those nodes. It should be noted that this is a very rare occasion within the Chef network setup. So let's step through a use case. In this instance, we're going to look at Hapoalim and how they used Chef. So Hapoalim is a bank, and it's the largest bank in Israel. And they have a mixture of Linux and Windows servers that they have to maintain. And as you can imagine, this requires a lot of constant configuration and work, and this has led to issues in the past. So the challenge that the team at Hapoalim faced was creating and hardening software that ran the major tasks and was repeatable on those servers, that it didn't matter who the people were performing the jobs, that there was consistency in the work that was being done, and address the problem that the servers, including the hardware on the servers, was not consistent throughout the organization. Chef addresses those specific problems and became the go-to product for Hapoalim. They were able to write the recipes and the cookbooks that could be deployed out to the network effectively. And it didn't matter what the system was, the recipes reflected the standards that the system administration team put together. And they were able to ensure and test each script and use standard testing tools for those scripts. It didn't matter what kind of environment that Hapoalim had, if certain ports need to be closed, or if a firewall needs to be installed or modified, or if custom strong passwords had to be created. All of this could be done using the recipes that Chef offers. And once those recipes had been finalized, they could be packaged into a common cookbook that could then be deployed to the entire network, ensuring a consistency in results for the company. And also, it didn't matter whether the cookbooks were being deployed to Linux or Windows machine, because the scripts were being put together in the recipes and were written in Ruby. You could actually go through and update and modify those scripts depending on the environment. So if you needed to make a modification for Linux, you could make those modifications so they were consistent across all the Linux servers or all the Windows servers. And this really drove in the ability to harden and secure the environment in the entire network within a matter of minutes using Chef versus the days and weeks that it previously took. So if we take a before and after scenario using Chef, before Chef, tasks were repeated multiple times, and it was just hard to keep track of all the people doing the work. And the reality is, because so many people were touching all the different systems, specific standards that the banks had established were simply not being met. After Chef, all of the tasks could be scripted using Ruby, and using the recipe and cookbook model that Chef has created, the Chef tool was able to deploy out to the entire network specific cookbooks that provided a consistent experience and consistent setup and operation environment for all the hardware. The end result is that the system administration team could guarantee that the standards of the bank were being met consistently. So just the takeaways that we have here of Chef. So life before Chef is complicated. If one server goes down, you can probably get it back up and running. But if you are working in a modern system administration environment, you have many systems, and if multiple systems start going down or having failure points, it is difficult to identify where those failure points are and how to solve them. Chef resolves this issue, and it does so by turning the environment that you're managing with hardware and software into code. And once you have it written as code, you're able to then test that code. Chef itself is made up of a number of key components. As a system administrator, you work on your desktop at your workstation and you create recipes. Those recipes are then bundled together into a cookbook, and that cookbook communicates with the server, the main Chef server, and the node of servers within your environment. And Knife is the tool that does that communication. Ohai and the Chef client on the various node servers will communicate back to the Chef server what the standards and the environment are, so that they can provide a two-way communication to validate that the system has been set up and is being maintained to the same standards as defined by the individual recipes. As an architect and working in this Chef environment, it makes it much easier for you to be able to control the entire system administration. Instead of having many people having to work on all the servers, you can now have one person controlling hundreds of servers simultaneously. And Hapoalim have been able to prove conclusively that Chef is the tool that can help improve the consistent experience of working with hardware. So I hope you enjoyed our quick class today. This is Matthew with Simplilearn and signing off. If you have any additional questions, reach out to us in the comments below and we'll get back to you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.